Let's just jump right into this, because we are looking at a truly mind-bending story today. Welcome to this explainer on our source material, the Radio Quran, Echoes of the Tireless Pulse. This is a fascinating narrative that bridges deeply complex astrophysics with ancient theological texts. It's a story about raw data, deep space, and honestly, what happens when two vastly different ways of looking at the universe collide in a single, repeating signal.
I mean, just think about that question for a second. What if the universe's most accurate clock suddenly spoke in a language from 1400 years ago? It sets the stage for an incredible journey of discovery. Imagine staring at cold, hard astrophysical data, the kind of numbers that dictate the sheer mechanics of the cosmos, and out of nowhere you recognize a phonetic pattern. And not just any pattern, but one that perfectly mirrors ancient Arabic scripture. It sounds completely like science fiction, right? Well, today we're going to walk exactly through how this specific scenario unfolded between two researchers studying the night sky.
All right, let's start with Section 1, the space clock and visitant.
The whole thing kicks off at the Meerkat Radio Telescope Array down in South Africa, and we've got these two scientists with, honestly, beautifully contrasting worldviews. On one side, there's Dr. Imran Al-Nadi. He's a pulsar timing expert, basically a visionary who's always looking for deeper cosmic patterns, and he's highly familiar with Quranic texts. On the other side is Dr. Frank de Villiers. Frank is your classic strict materialist astrophysicist and a hardcore skeptic. To Frank, data is just data. It's just quantum mechanics acting on a star's surface, no hidden meanings, no mystical visitors hiding in the static, just numbers.
Now, their research focuses exclusively on something called millisecond pulsars. If you're not super familiar with them, a millisecond pulsar is a super dense neutron star. They're essentially the leftover, collapsed cores of dead stars, and they are denser than literally anything in our solar system. Because they spin so incredibly fast and are so predictably stable, they act as the universe's most accurate clocks. They send out these intense beams of electromagnetic radiation that sweep across space, kind of like a massive cosmic lighthouse.
To really wrap your head around the sheer scale of the physics here, just look at this number, 100 to 1,000. These stars rotate an astonishing 100 to 1,000 times every single second. Imagine an object with the mass of our entire sun, squished down into a sphere the size of a city, spinning hundreds of times in the blink of an eye. It's wild. And it's exactly this level of extreme precision that allowed Dr. Imran and Dr. Frank to detect even the tiniest, most minute anomalies in the star's rhythm.
Moving on to Section 2, the mysterious pulse glitch.
So, even the most perfect cosmic clocks occasionally stutter. While they were analyzing 10 years of timing data from a very specific 5.7 millisecond pulsar, its catchy name is PSRJ 04374715, Imran noticed something super bizarre. The star's spin-down rate, which is the tiny amount it naturally slows down over time, wasn't just randomly glitching. Actually, scratch that, it wasn't random at all. It formed a highly structured repeating mathematical pattern known as a logarithmic spiral. The derivative of this decay hit a very specific peak exactly every 100 days, and then it repeated the cycle flawlessly.
Naturally, Frank immediately brushed this off. To him, it was just background timing noise, nothing to see here. But Imran had a totally different theory. He suspected a connection to verses in Surah at-Tariq from the Quran. Those verses actually talk about the night visitant, or knocker, known as Tariq, and the piercing star, known as Najm Thaqib. Imran started to wonder, what if these weren't just poetic metaphors? What if they were literal descriptions of a pulsar's knocking radio waves and its piercing magnetic beams?
Let's look at Section 3, Cosmic Transformation of Sound.
To test this deeply out-of-the-box theory, Imran decided to transform the raw dataset into something that our human ears could actually hear. By using a really cool process called sonification, he converted the timing gaps into an acoustic output. Basically, he took the 10-year timing residual and applied a Fourier transform, which converts time into frequency. Then he isolated this ultra-sharp, completely non-random peak at exactly 0.0001 Hertz. Finally, he ran an audio sonification program to translate that specific data peak directly into audible sound.
And the result? Absolutely mind-blowing. The source material describes the sound not as some static hiss, but as a deep, metallic knock. It repeated every 100 beats, followed by a drawn-out sound. Astonishingly, this output flawlessly mirrored the plosive and tap phonetics of the Arabic word tariq. I mean, it literally sounded exactly like someone knocking heavily on a huge metallic doorway way out in deep space.
Which brings us to Section 4, the scientists' disbelief and proof.
As you might guess, this is exactly where the rigorous scientific pushback comes in. Frank, holding strong to his skepticism, basically refused to accept this acoustic mapping. So he built a synthetic pulsar model in the Meerkat signal generator just to debunk Imran's findings. He followed 3 strict steps. First, he cloned the exact spectral density of Imran's data. Second, he added 20 distinct frequency components to create a multi-tone match. And third, he generated a synthetic signal. He fully expected it to produce the exact same phonetic taric sound, which would prove it was just a byproduct of the frequency spectrum, not some unique physical property of the star.
But his synthetic model failed completely. Instead of that rhythmic knocking, the output was just random white noise. So, why did it fail? Well, as Imran pointed out, Frank only cloned the linear spectrum. He completely missed the time-dependent geometry and the relaxation time that naturally exists in a real neutron star's coupled magnetic particle flow. It turns out it was that exact physical relaxation time of the star that matched the human vocal release of those specific Arabic letters. There was no way around it.
Okay, this is absolutely crucial. Look at how the physics directly map to the linguistics here. It brilliantly illustrates the exact parallels Imran found. The star's specific breaking index of 2.9999, it perfectly matches the 3-tier glottal plosive of the Arabic letter ta. The 150 kiloelectron-volt hard X-ray peak, that aligns beautifully with the uvular plosive of Qaf. And incredibly, the logarithmic decay of the particle acceleration perfectly matches the 1.2-second prolongation, or mad, of the phrase ma adraka when the verse is recited. Just let that sink in.
All right, Section 5. The universe is radio tasbih.
The whole narrative reaches its absolute climax when the team decides to expand their scope, beyond just a single star. They thought, if this is true for one pulsar, what happens when we look at the broader night sky? So Imran looked at 3 completely different pulsars: PSR B1919 plus 21, PSR J0108-1431, and the Vela pulsar. When he mapped out their magnetic polarization swings, he uncovered another visually stunning pattern. The spiral curvature of their polarization swings consistently matched the exact 3D calligraphy of the Arabic letter sin, which happens to be the prominent letter in the word sama, meaning sky in that very same Quranic verse. When Frank overlaid the phase diagrams of all 3 stars in his supercomputer, he experienced a profound emotional realization. Seeing a 3-dimensional mathematical space perfectly align with the ancient text, he finally said, 3 different stars, 3 different distances, this cannot be a random coincidence. The skeptic had finally seen the undeniable structure hiding within the noise.
Eventually, these 2 scientists took their findings global. At the International Radio Astronomy Conference, they presented an overlap of 2 datasets. In red, they showed the timing residual of the pulsar, and in blue, the vocal audio spectrogram of a human reciting verses 1 through 3 of Surah At-Tariq. The visual match between the deep space data and the human vocalization was an astonishing 99.9%. For sure, Frank publicly conceded right then and there that the universe's most accurate clock was indeed transmitting this specific, undeniable rhythm.
And, according to our source, this revelation hasn't just faded away as some fascinating little anecdote, it's actually birthed an entirely new field of study. There is now a dedicated At-Tariq Pulsar Timing Consortium. They analyze 50 different pulsars every single month. And you know what they're finding? It's perfectly consistent. Pulsars with stronger magnetic fields produce even sharper, clearer acoustic matches to these ancient phonetics. It's a real game changer.
So as we wrap up today's explainer, I want to leave you with a final thought derived directly from the source material. Is the rhythmic, metallic pulse of the night sky merely a byproduct of cold, unfeeling quantum mechanics, or is it an undeniable structural call from the universe itself? It's an absolutely incredible intersection of rigorous data analysis and ancient language. Keep that in mind tonight when you look up at the stars. Thanks so much for joining me, and keep exploring the incredible patterns of our universe.